So before I am going for numericals, just to tell me the formulas based on what we learned till now, the basic formulas. So V is equal to, shall I write I into Z, where Z is nothing but, what is the formula of Z? R plus Jx. If it is inductive reactance, XL. If both are combined, then it will be XL minus XC, that is capacitive reactance, inductive reactance. Or else simply you can mention as Z is equal to R plus Jx, where X is net reactance. The value is this one. What is the formula of XL in terms of omega? XL formula in terms of omega.
Omega LC.
Omega 59.
LC.
I am asking the inductive reactance XL.
V by
V by
L.
No. Inductive reactance.
Omega L.
Very good. No. Omega into L. Where omega is, once again, expand omega.
2 pi F.
Very good. 2 pi f L. Now Xc is equal to, what is the formula?
1 by omega C.
Very good. 1 by omega c. Where omega is again 2 pi f.
1 by 2 pi.
Right, very good. Now all these formulas already we discussed how these are came, what is the analysis part in last 3 sessions, right? Revise perfectly. And what else the formulas? RMS. RMS value is equal to, VRMS equal to, what is the formula? Conclusion for sine wave. VRMS, V average,
Sure.
VRMS formula.
Vm by root 2.
Very good. And V average?
Vm by root 2.
V average.
Vrm 2Im 2Vm by pi.
Very good. 2 Vm by pi. If they are asking I average, then it will be 2 Im by pi. If it is a current, we should be replaced with I. Right. What is the equation of voltage? V is equal to Vm sine omega t. If in the case of current, it is Im sine omega t. If there is
Im sin omega t.
right, if there is any lead or lag conditions are presented, let us take an example. Inductor. Now I am taking example of inductor. The reference parameter is voltage. Then the current equation will become as how we can represent the lag condition. Inductor in the sense current lags voltage, right?
Yes.
I lags V by, let us take some pure inductor, then angle is 90 degrees. So we know the equation is I equal to Im sin omega t, but it is inductor presented, therefore it should be maintaining an angle lag of 90 degrees. So lag in the sense it will be downward, that is minus 90. The equation now change it to sin of omega t minus 90. If it is a capacitor, then the same equation will be updated as sin of omega t plus 90. So here the plus indicates leading. In capacitor, current leading the voltage by 90, right?
90 degree.
In inductor, it is lags. So lags in the sense the polarity should be negative. Leading in the sense polarity is positive. Remember how to identify whether the given equation is lagging or leading as per the given data in the problem. Correct. And is there any still formulas we need to revise? Individual capacitive reactance XC already we have written 1 by omega C.
Net reactance.
What about the voltages which are presented across the resistance and across inductor, across capacitor? Voltage presented across resistor, that is I into R. Voltage presented across inductor, I into corresponding inductive reactance. Voltage presented across capacitor, I into corresponding capacitive reactance, where XL we know the formula, XC we know the formula, right? From this we can calculate I value. I equal to VR by R, I equal to VL by XL, I equal to VC by XC. Now always remember, for any problem in unit number 2, if they are mentioning the values like 230 volts, 50 Hz, without mentioning whether it is a maximum value or average value or RMS value, by default you have to consider this as a RMS value. Understood? Voltage RMS ORR. Similarly, they also mentioned some 20 amperes. It draws 20 amperes, the total current. Then that will be, we can consider as IRMS. Right, understood? In AC analysis, the RMS values are by default we can represent. Right, clear about how to do the numericals? Shall we start? The formulas are in front of you. The notations are also there. Right. Note down one problem. An AC circuit consisting of an AC circuit consisting of a pure resistance of 20 ohms and is connected to an AC supply of 250 volts, 50 hertz. Then determine the first one, current flowing through circuit, and the second one, power absorbed by the circuit, and also they asked the equations of voltage and current. Voltage and current. So note down the problem and try to get the given data with our electrical terminology notations and try to solve it. Noted more? Write down the given data. Why is my handwriting is able to understand this screen? Okay, fine. Do it, do it. What they are given 20 ohms resistance they mentioned. First, you try to draw the circuit. What is the given circuit? What they are given. So try to draw the circuit as per the given data. So here given data is 250 volts, comma 50 hertz. They clearly mentioned the value of the voltage. So therefore we are having one voltage source which is connected across 20 ohm resistance. Now I am going to draw the circuit. So this is the resistance value they given as 20 ohms and the supply voltage mentioned as 250 volts, which is having a frequency of 50 hertz. Since it is a sinusoidal representation, I given the symbolic connotation of sine. Right. Now, let us note it down the given data. R value 20 ohms and VRMS they directly given as 250 volts and the value of frequency 50 hertz. What they are asking in first problem, current flowing through the circuit. What is the formula of current? In case of
V by R.
very good, V by R. So here the value of V is 250. I will write the formula first. V by R. So the value of V given is 250 and R value 20. How much current?
12.5.
12.5 amperes. And the B bit, power absorbed by the circuit. What is the formula of power absorbed by the resistance? What is the formula? What is the formula of power absorbed by a resistor? You can take any of the formula. You are having different formulas for calculation of power, right? Anyone can tell me the formulas of power?
I.
Right, V into I. You can also use that V into I. Here, what is the value of V? They given as 250. Value of I 12.5. Tell me the value of power.
3125.
3125. Right, very good. 3125. What are the units for power?
What?
Watt. Very good, watts. And the last parameter they are asking the equations of the voltage and current. So equations of voltage and current in the sense, now tell me the equation of voltage. V is equals to Vm sine omega t. So here what is the value of Vm? Are they given in the problem? Maximum value of voltage?
No, sir.
No, therefore we need to calculate Vm value as a separate. So how to calculate Vm? They given VRMS. What is the relation between VRMS and Vm?
Vm by root 2.
Right, Vm by root 2. VRMS they mentioned as 250. So Vm by root 2. Then what is the value of Vm now? 250 into root 2. How much?
Three 55, sir.
3. How much?
353.55.
Okay, 353. Let us I am concluding that as some 354 or 353.5 volts. Now similarly, now just substitute here. Later we will go for current equation. Vm value is 353.5 sine of omega. Again, omega we don't know. Omega formula. Omega is equals to 2 pi f. The given frequency value as 50 hertz. So 2 pi into 50, how much?
Three one four.
314. Very good. Now sine of 314 into t. This is what they are asking as a third bit. Voltage equation. And also they are asking about current equations. Now will you solve by your own current equation? I is equals to Im sine omega t. Now here I did not mentioning any phi value plus 90 or minus 90 because it is a pure resistance. In the case of resistance, both V and I are in phase, right? There is no phase angle difference between them for the case of resistor. Now calculate the current equation. Omega value should be remains the same, 2 by f. Im value you need to calculate. So IRMS is equal to Im by root 2. From this, Im is equals to root 2 into what is IRMS value? They given as no, we are calculated 12.5. 12.5. How much?
Seventeen point six seven.
17.67. All of you getting the same values?
Yes, sir.
Amperes. Now just I'm substituting it in equation of current. I is equals to 17.67 sine of 314 t. Completed. Done whatever they are asking in the problem. But just we are applying our content. There is no difficulty in doing the problems. The way we are approaching for the solution is very important. If we are strong at our theoretical concept, then we can apply it to our numericals. Note it down quickly so that we will move on to another problem, which consisting of inductor. Noted. Shall we move for another problem? Shall we go for next problem now? Noted all of you?
1 minute.
Okay. Okay. If complete, we will go for a problem which consisting of a capacitor and inductors. I think yesterday I given one problem, right? By combining all these three parameters, resistor, inductor, and capacitor for series combination. Is there anyone did that? Calculation of impedance, calculation of circuit current, calculation of power factor. Power factor, you can leave it. I will tell today. Anyone tried that problem?
No, sir.
Why? The formulas are in front of you. Calculation of impedance. This is the formula. If all the three parameters are presented, resistance, inductive reactance, capacitive reactance. Now try to do that problem so that we will cover both L and C parameters at a time.